Naive-Bayes classifiers are a collection of classification algorithms based on Bayes' theorem. It is not a single algorithm but a family of algorithms where all of them share a common principle, that is, every pair of features being classified is independent of each other. There are two important things that we need to understand, that is, we assume that no pair of features are dependent. Secondly, each pair is given the same level of importance. There is an important note that we need to make, that is, the assumptions made by Naive-Bayes are not generally correct in real world situations. In fact, the independence assumption is never correct but often works well in practice. When the predictors take up a continuous value and are not discrete, we assume that these values are sampled from a Gaussian distribution. Since the way the values are present in the dataset changes, the formula for conditional probability is given as shown in the presented PPT. To start with, let us consider a dataset to describe this example. First, suppose consider a fictional dataset that describes the weather conditions for playing a game of golf. Given the weather conditions, each tuple classifies the conditions as fit is yes or unfit is no for playing golf. Similarly, for this example, the temperature is naturally of these continuous values, yes and no. Here, some of the values for yes are shown and some of the values for no are shown. Now we need to estimate the mean and variance for each class, which is calculated using the formula shown in this current PPT. Also, the output for two Gaussian models was also shown here in the current PPT, and it was solved using the formula that was described in the previous slide. And it is for two, like it is for yes, and also the probability calculation for yes and also probability calculation for no. So this shows the output of these two Gaussian models. To separate the columns into dependent and independent variables, we split those variables into two sets, that is, one is train set and the other is a testing set. The algorithm for training in Naive-Bayes is shown in the current slide. This is the algorithm for training set. This algorithm shows testing of Naive-Bayes. To conclude, Naive-Bayes algorithms are mostly used in sentiment analysis, spam filtering, recommendation systems, etc. They are fast and easy to implement, but their biggest disadvantage is that the requirement of predictors to be independent. In most of the real-life cases, the predictors are dependent. This hinders the performance of the classifier. Estimate parameters from the training corpus using advanced smoothing is one of the important points of Naive-Bayes classification. For a new document, for each class, compute sum of log of prior, logs of conditional probabilities of the terms. Assign the document to the class with the largest score or the largest value is one of the important primary point of Naive-Bayes classification.